Hi folks, this is Calc 2, Checkpoint Quiz 2. We're given half a dozen integrals to work on today. So let's get going. Number 1, we're asked to integrate 4 over x from x equals 1 to x equals 2e. Now before we get started, we want to check the function 4 over x has a big problem at x equals 0. We have to make sure that we're not integrating through that discontinuity, and in fact we're not, because, well, 1 is certainly far enough away from 0. And remember, the number e is roughly 2.78-ish, so 2 times e is going to be bigger than 1, and so we're integrating on an interval where our integrand is continuous. That means we can use the fundamental theorem of calculus. So I'm going to get started by factoring the 4 out front of the integral. And now I'm going to use our integration formula for the natural log. We know that the indefinite integral 1 over u du is the natural log of the absolute value of u plus c. And so that's exactly what I have here with the x. So it's 4 natural log absolute value of x. And I'm using the fundamental theorem of calculus now. I'm going to evaluate that from x equals 1 to x equals 2e. So I substitute in the top limit of integration. I get 4 natural log the absolute value of 2e minus 4 natural log absolute value of 1. Since both 2e and 1 are positive numbers, the absolute value of 2e is just 2e, and the absolute value of 1 is just 1. Now we know by definition the natural log of 1 is 0. And so we could just be happy with this answer. But remember, depending on what's going on in the back of the book, we can use log properties here. We can rewrite the natural log of 2 times e as the natural log of 2 plus the natural log of e. And by definition, we know the natural log of e is 1. And so another form we could see would be 4 natural log of 2 plus 4 times 1, which is 4. But, once again, there may be in the back of the book, if this were a problem in the book, they may put the 4 up on the 2 as an exponent. And they could write this then as the natural log of 2 to the 4th, which is natural log of 16 plus 4. So just a couple different ways they could have written the answer. Anyway, no matter how you do it, that's it for number 1. All right, number 2, we have another definite integral. And once again, we would like to use the fundamental theorem of calculus on this. But we need to check to make sure the integrand is okay on the interval 0 to pi over 3. So secant of x is also known as 1 divided by the cosine of x. So if the cosine of x is 0, we're going to be in trouble. Well, the cosine of x is 0 when x is plus or minus pi over 2, and the odd multiples of pi over 2 out from there. So on the interval 0 to 3, this function is continuous, which means we can use the fundamental theorem of calculus. So to do that, we need to know the antiderivative of secant of x. And we know from our work in class that the antiderivative secant of u du is the natural log of the absolute value secant u plus tangent u plus c. That's one form, or you could use the form negative natural log absolute value secant u minus tangent u plus c. I'm just going to stick with the top form here. And so using the fundamental theorem of calculus, I get the natural log of the absolute value secant of x plus tangent of x. And I'm evaluating this from x equals 0 to x equals pi over 3. So this is equal to the natural log of the absolute value secant of pi over 3 plus tangent of pi over 3 minus the natural log of the absolute value secant of 0 plus tangent of 0. This is equal to the natural log of the absolute value. Secant of pi over 3 is 1 over the cosine of pi over 3. The cosine of pi over 3 is a half, so the secant is 2, plus the tangent of pi over 3, that's square root 3, minus the natural log of the absolute value. Secant of 0 is 1, tangent of 0 is 0. And so I get the natural log of 2 plus radical 3. I don't need the absolute values anymore because both of those are positive and I'm adding them together. Minus the natural log of 1. And by definition, the natural log of 1 is 0. So this gives us our final answer, natural log of 2 plus square root 3. Now, even though we're not asked to do so, geometrically, what are we doing? Since the secant function is positive on the interval 0 pi over 3, we can graph that. Secant of 0 is 1. Secant of pi over 3 is 2. What we're actually doing with this integral is finding the area between the curve y equals secant x and the x-axis on the interval 0 pi over 3, and that works out to be this number. Okay? Just a geometric spin on this problem. Anyway, that'll do it for number 2. Okay, in number 3 we have an indefinite integral, so we're just looking for antiderivative of x squared minus 4 divided by 3x dx. And we have a numerator, and since we have the subtraction happening in the numerator, we can split this up to get x squared over 3x minus 4 over 3x dx. And this simplifies then to x over 3 minus 4 over 3x dx. Okay, so let's just keep going here. The first term, that's 1/3 integral x dx minus 4/3 integral 1 over x dx. This is a Calc 1 integral. That gives me x squared over 2 minus, this is our new form, which gives us the natural log. And of course we have our ubiquitous c, and so our final answer, the integral of x squared minus 4 divided by 3x dx, is 1/6 x squared minus 4/3 natural log absolute value of x plus c. So that'll do it for number 3. Oh, I should mention, the ultimate check to these antiderivatives is to take the derivative, do some algebra, and see if you arrive back at the integrand. So in other words, you take your answer here, take the derivative and do some algebra, and see if you get this expression here. Okay, so that'll do it for number 3.